it's somewhat common to have a need to be able to find the angle between two different vectors. So let's take a look at this and let's approach this directly with an example. And let's suppose that vector A is 2, 1, 3 and B is 4, 3, 3. Now remember, these are position vectors. A is a position vector of the point 2, 1, 3 and B is a position vector of the point 4, 3, 3. So both vectors go from the origin to their respective points. That's what it means to be a position vector. So we know from the definition of the dot product, we know that A dot B equals the magnitude of A times the magnitude of B times cosine of theta, the angle between them. With simple algebra, that would imply then that cosine of theta must be A dot B divided by the magnitude of A times the magnitude of B, which would then of course imply that theta equals arc cosine of A dot B divided by the magnitude of A times the magnitude of B. Okay, so can we find these? Well, yeah, because A dot B, because this is in component form, is going to be 2 times 4 plus 1 times 3 plus 3 times 3, which is what? 8 plus 3 plus 9. So that obviously is 20. And then we need to divide that by the magnitudes multiplied together. So let's find the magnitude of A first. Magnitude of A is going to be square root of 2 squared plus 1 squared plus 3 squared, which is the square root of 4 plus 1 plus 9, which is root 14. And the magnitude of B is going to be the square root of 4 squared plus 3 squared plus 3 squared, which is the square root of 16 plus 9 plus 9, which is 34. So this is going to be root 34. So cosine of theta is going to be 20 over the square root of 14 times 34, which is not a lot that I can do with that. 14 is 2 times 7, and 34 is 2 times 17, so I could write this as 2 times the square root of 7 times 17, which is 119, and obviously that will cancel, make this 10. So cosine theta is 10 over root 119, clearly not a common angle. That would then imply that theta itself, the actual angle between these two vectors, is going to be arc cosine of 10 over root 119, which is approximately, if we're thinking in terms of degrees, 23.5519 degrees. So if you're rounding, roughly 24 degrees, which is also approximately 0.4111 radians. So depending if you're working on degrees or radians, that's the angle between these two vectors when these vectors are given to us in component form.